Alright guys, so let's solve the last question on your homework of Atwood machines. That's a little bit different than the others because the free body diagram for this case is not going to be as simple as you might be thinking. Alright, let's get started. For part A, they are asking for if the platform and person are at rest, what is the tension in the rope? And for this question, it's very important that you choose the correct object to draw the free body diagram to find the tension, because tension is acting in two objects. And one object is the guy, the other object is the elevator or the platform. So if you choose the guy, the person, free body diagram of the person is going to be as follows. It's going to have mg, which is his weight, and that's going to be his mass times gravity, which is 800 newtons. And you're going to have tension because he is holding one of the string, and then he is actually in contact with this platform, so that will also require some normal force. And then you're going to have three different forces, but you only know one of the forces. You don't know two other forces in that system, and that is not going to allow, or that's not going to help you to find a tension force. Then you need to go to the platform. And platform's free body diagram is going to be a little bit different as well. Let me draw the picture first. So you're going to have this tension that is obvious, and your mass of the platform will basically the mass of the platform plus the person. So this entire thing can be taken as one object, and that's 100 kilograms. So you have 100 kilogram object, and you have a tension from right above it, but you have another tension that is coming on the side. So if you think about it, yes, the person is holding the string, but it is technically attached to the platform again. So consider, instead of that person, and let's say that string is attached somewhere here, okay? It's not like a person is holding it, but it's the string that is just attached to the platform. So if that was the case, then it would be a little bit easier to think about it. So you would have that tension, and then this same string is attached to the platform again. So you would have this F tension 2 times, right? Because your string is attached to the platform and the person system twice. One is right above, so that's clear to see, but it is kind of difficult to see this guy. But this string is also attached to that platform person system. So that means that tension force is, since it's the same string, there's no any other string, same string is going to have the same force. So you're going to have the same tension force acting on the platform and person system twice. And my force that is going down, if you would like to make it separate, M person G, and then you also have M platform. Wow. Let's put M man. And don't tell me that's sexist. I just call a man, okay? And it seems like a man. Anyways, so mass of the man times gravity and mass of the platform times gravity. So basically that is going to be the free body diagram of your system in this case. So, and once you have that free body diagram, you're going to have 2 times Ft, that is going up, and then you're going to have mass of the man plus mass of the platform times g, and that is going to be equal to mass times acceleration. And they say this system is at rest. That means no acceleration. So that means 2 times F tension is going to be equal to 80 plus 20, which is 100 times 10. So that's going to be equal to 1,000. So I just take all of this to the other side. So this entire thing is 1,000, or I'm not going to do. So 2 force tension is equal to negative mass of the platform and the man times gravity. So basically 2Ft is going to be man times platform is going to be 100 kilogram, 100 times g will be 1,000 newtons. So 2Ft minus 1,000 is equal to 0. So 2Ft is equal to 500. Then your 1,000. So your F tension will be equal to 500 newtons. And part B, this time, this person on the platform is pulling the string down and the system is accelerating with a rate of 2 meters per second squared, and they're asking for the tension in that new case. It is going to be pretty similar to the one that we had in the first question, and let's write it down. So for part B, you have this similar system. You have Ft going up, and then Ft going up, and then let's put that as just one object. 80 plus 20 times g, which is 1,000 newtons. So my free body diagram is the same. 2 tensions going up, 1,000 newtons going down. The only difference this time is my system is not at rest. I am accelerating my platform upwards with a rate of 2 meters per second squared. So my 2F tension minus 1,000 will be equal to mass. And the mass that is moving with that much of force is simply 100 kg times acceleration. And my acceleration this time is not 0, it is 2. So, and it's going upward, so it's going to be positive 2. Then 2F tension will be equal to 1,000, going to go to the other side, and you're going to have 200 over there, so that's going to be 1,200. So my tension in this case will be equal to 600 newtons. And now they are asking for the normal force acting on the person. And they're asking for that force when you are actually accelerating upwards. So let's put part C right there. So since they're asking for normal force on a person, we need to draw the free body diagram of the person. And let's figure out, we had it over there, but let's do this again. Fg is acting on the person, and what is the gravitational force acting on the person? It's always mass times gravity. So you know the mass of the person and you know the gravity, so that is going to be 800 newtons. And then what else we're going to have? This guy is in contact with the string, and string is straight up, so that's F tension going up. And then this guy is also in contact with the surface. That means you will also have the normal force. And we found that tension force when this guy is accelerating upward, and this tension force is 600 newtons. And now, as you can see, I have 3 forces in my system and I know 2 of them. Then it's going to be easy to find the last force. All we need to do is write all of the forces acting on the object. So total force, total force equals mass times acceleration. I have 3 forces, 2 goes up, 1 goes down. So going up forces would be written as positive Fn plus Ft. They are going up, they are positive, minus Fg because it's going downward. So let's put that as Fg, and that's equal to mass times acceleration. Fn is the unknown, plus tension, we had found it in the previous part, that's 600 minus my gravitational force acting on the object is 800, and that's equal to mass times acceleration. And my mass is, we're talking about this is the free body diagram of the person, and person weighs 80 kilograms. Wow, that guy's fat. Alright, times acceleration. And acceleration will be given, and that is 2 meters per second square, and he is going up, so that's going to be positive. Then what do we have over here? Fn minus 200 equals 160. 200 goes to the other side, your Fn will become 360 newtons. Alright, so that is the solution for part C. And part D, you are not going to be responsible, you don't have to solve it, but just not to leave it blank, I would like to solve it. So in part D, they're asking for they're asking for power output. And power is going to be rate of work that you do. So it's basically work divided by time. And work, in this case, force times distance, or force times displacement over time. And the force that we are actually applying, the force that is acted on the person, is his weight. So it is going to be mg. So mg divided by mg times delta x divided by time. And over here, we know the mass of the person, we know gravity, but we don't know how much it goes up and how long it takes. However, we know that delta x over time, you should remember that, distance over time gives you velocity. So your power will be mass times gravity times velocity of the object. And now I think it's going to be clear. Mass of that platform men is going to be 100, and gravity is 10, and my velocity is 0.4, so that is going to be basically power output, and that is 400 watts of power, and that is going to be it.